Now to combat the issue with pod failing, dying, and being replaced with new IPs, Kubernetes introduced a new object called service. And what this service does is it controls access into the pod. And then it controls access outside of the pod. This is what it does, right? So if you want to access now, you use service, right? And what this one does is you write a manifest file of service and post it to API server. And what this one does is it exposes the network protocol of port. So now this eradicates the IPs of pods changing every time it dies. Every time it dies, right? So how does service achieve this? And it's actually very simple. So Kubernetes came up with a very brilliant solution of how to do this. So I'll clean the board. And the concept is just by using labels and selector, right? In a pod, you specify a label. And in a service, you specify a selector, right? In a service, you specify a selector. And anywhere the selector finds this label and they are of the same thing, it will attach itself to it. So let's see it. Let's say, for instance, a label have a metadata which contains information of a pod, and it has labels, and the labels is app, pod A, and a service as well have its own metadata and as selector of pod A. Let's say the selector is app pod A. This will automatically attach. So if this pod dies, let's say this pod dies and starts again, if it dies and starts again, as long as it has this label, this service will always attach to it. And the beauty of service is just that service have reliable or stable IPs, unlike pods. And then they can even have DNS, and they have reliable ports as well, right? This makes service really very good for this kind of work. So let's see the essence. Let's see the essence in a diagram and just learn more about how this works. So let's say, for instance, a client is trying to access our pod in a Kubernetes cluster, right? This is a client, or let's call it a user. And then the client is going to connect through a service, which is now reliable, which has DNS, and it has reliable or stable port, right? Unlike if it tries to access a pod, through a pod directly and the pod dies, it changes. No, this one doesn't change. This is good. And as long as these pods have labels that are similar to the selector of this service, even if they die, they will always have the service IP, right? So they will always attach themselves to the service, or the service attach itself to it. So let's see that in action. So what I've done is I've created a folder called 01 tutorial service, and I'm going to write 01 pod here, 02 pod, and the service for this, right? So we are going to just copy this. Let's copy this and this is going to show the solution to eradicate the problem with IPs changing. Remember the last class. If you have not watched it, please go and watch the last class. Right, so I'm going to go to pod 1, going to paste this, and here I'm going to add labels, and I'm going to say app is pod A. Great. And then we are going to create a service, and the service is going to have a selector that attach itself to these labels. So let's save this, and let's create that. I'm going to say API version, and it's V1. And I'm going to say the kind is service. And the service has to be capital letter. Please don't forget that. And I'm going to say metadata, which will contain the details of the service. And I'm going to say the name of the service is pod A service. And I'm going to say it's okay, yeah, great. This is not where I'm going to say specification, right? And I'm going to choose selector here. And I'm going to say the selector must map to pod A, right? So this is it, selector, and it's mapping to this. Anywhere it finds this, that is where it's going to attach itself to. So I'm going to say this, and I'm going to say port, and I'm going to say port, I should say minus first, say port is 80, and this is where our service is going to listen on, and I'm going to say target port 5678. I'm saying any port that you see listening on this, says if the selector is at port A, and the target port is 5678, right? I'm exposing you through this, and then we are going to show you through port 80, and I'll see what I mean. So, and you see what I mean. So if I go back to port B, let's just copy and paste port B. You're not going to change anything in port B. Where is it? Port B. Let's just Control C. It's the same thing. I'm going to paste it here and close the one for 01 tutorial. I'm going to say S. Now, the first thing we are going to do is we are going to create this pod and then run its service to make sure that the service, instead of using this private IP, we are going to use the private IP of this service, right? So even if this pod fails in the future, nothing is going to go wrong. And then we are going to substitute the service, the IP of the service here. We'll remove the 5678 because it's listed on port 80. We don't need it, right? So let's try it. Let's see it. So I'll go here, and I'm going to say inside the folder that I just created, I'm going to say kubectl, and make sure you save everything because that might return error. And I'm going to say 01, and that's port A. Port A is where we are going first to create. And we've created port A. If we see a kubectl get port O wide, and we see it, and this is the IP of port A, which we are not going to use. Remember, we say it's ephemeral. It changes when port fails, dies, node fails, and all that. So now, second step is to create the service, and this service is in 03. I hope I'm right. And once we create this, and the service is created. So if we say kubectl get svc, and I'm going to say ho wide, that's how to get service, right? You can say get svc, you can say this to give you more information, and it's telling us this is our IP, right? And don't worry, it's saying cluster IP. We are going to discuss this right after explaining this. And then we have this IP. And that's what we are going to put in our port B. So this is 10.102.2.0. So I'm going to go back here. Let me just copy and paste. Copy this. And I'm going to come back to our port B. So instead of using our private IP of port A, we are just going to use this one of service. Great. And since it's listening on port 80, we can write this, or we can leave it this way. It's the default port. It doesn't matter. But for people that may not understand, I will just leave it at port 80, right? And that's where our service is listening. Our service is listening on port 80. This is the port right here, right? With port forwarding. And you see selector, which matches the label, of port A, right? This is the label of port A. So let's create our port B, apply -F, and I'm going to say 02, port B, and it's created. And if I say kubectl get all, we see everything. And this is still creating, container creating, and let's wait for it to run. Then we are going to see the log. So I'm going to say kubectl get pods one more time, and it's running. Now let's check the log. Say kubectl logs -f pod B, and if you see it, hello from pod A, hello from pod A, hello from pod A. Now if I say Ctrl+C, now what I'm going to do, remember the last time we terminated pod A, right? We terminated it so that we see and we restarted it. So this time I'll say kubectl delete pod. And we say pod A, that's the name. Right, once we delete it, of course, it's going to stop. But we want to create it again. And once we create it, we are going to have a new IP. But since we are not using this new IP, this is the old IP. Once we create the pod again, it's going to have new IP. But since we are using the service one, which is even stable, right? So let's create pod A again. And I'm going to say kubectl apply -F 01 pod A, and it's going to create it. And I'm going to say kubectl get pod O wide, and it's running. And if you look at pod A now, it's having .28, which is the IP, has changed as usual, right? Before it was .26, now it's .28, right? But now if we go again to our pod B to get the logs, and see -F and check our pod B, you'll see that it's still going to be working. Hello from pod A, and see, hello from pod A. Another one will come again after 5 seconds. Hello from pod A, right? So we've eradicated this IP changing of pod. So most times, this is how you do it to make sure that everything goes well in your Kubernetes cluster. And we saw something. We saw cluster IP. So service have different types, right? And we'll break it down. Service have different types. And I will say service type. And the first one is the one that we just see, that we saw not quite long, and it's called cluster IP. That's first one. And then we have another one called node port, and we have another one called load balancer, and we have another one called external name. Now, when you want to access your pod inside the Kubernetes cluster, this is what you have, right? So if you look at this, you have cluster IP here. That means we are trying to access it from inside, right? Anything you are accessing through cluster IP is going to be pods communicating with one another without exposing themselves outside the cluster, right? It's inside the cluster. Communication within a cluster. Those are what cluster IPs is for, right? And then we have node pods. And if you want to expose your application or pod outside the cluster, and we're going to look at this when we are working on our project that we containerized, right, on our simple login API. Right, so that's how it works, expose outside. And this service type is when you want to use a load balancer, for instance, a cloud load balancer in AWS or GCP, right? AWS or GCP. You just specify your service type as load balancer and it will automatically create a load balancer for you. Automatically create a load balancer for you. And this one service type for external name is, if, for example, you want to use app.com or app.facebook.com or wherever domain name is for you. This is what we just use this external name for. So it works with DNS. So this is, and all of these are always what? Stable and reliable. Right, so this is what service type. So the next one we're going to see our application next. So our application, how we can make it the pod, the service part of it, then this thing, replica set and all that. So yeah, so what we are going to see after this object, we are going to see replica set and deployment. So that way we understand replica sets and deployment before we go. So let's see how it goes.